In this video, I'm going to talk about how to analyze an object that's on an incline and also has friction acting on it. So I'm going to draw an incline here, and what I'm going to do is I'm going to increase this angle just until the object's on the verge of movement. In other words, any further increase in angle will make it move. It's just teetering on movement. So this is going to happen at an angle of 47 degrees, I figured. And let's say the mass of this object is 10 kilograms. So my goal here is to find out what the coefficient of static friction is, mu s. So again, I'm going to raise the angle until this one's on the verge of movement, so it's not moving, so it's static, but any further increase in the angle will cause it to move. So the first thing I'm going to do is I'm going to draw an FBD again. So again, as we did in the previous video, draw the object at an angle. So I have, from the center of mass, I have mg sine theta. I have mg cosine theta. I have f of n, the normal force, and also I have a frictional force that's holding it up. Friction static. mg sine, mg cosine, my normal force f of n, and my static frictional force. Notice how I draw at the trailing edge. If it were to move, it would be trailing back here. Script f s. So again, I'm going to tilt my axes, so my positive x-axis is going to point this way. My positive y-axis is going to point diagonally upward. Okay, and in my new x direction, I have two forces. I have mg sine theta minus f static, and it's not accelerating, so I'm going to put 0 here. In the y direction, I'm going to have fn minus mg cosine theta, and that's also equal to 0 because it's not accelerating in the y direction. And then when you do a force problem, you actually have one extra equation. You have a supplemental equation. This is on the AP equation sheet and the force model sheet. The frictional force is equal to the coefficient of friction times the normal force. And remember that this has a unit of a Newton. This has a unit of a Newton because they're both forces. So in order for this to be an equality, this has to be unitless. So we just say unit of 1. That's the way we write unitless, as opposed to writing the whole word unitless. This is the coefficient of friction, the frictional force, and the normal force. So we get a third equation when friction's involved. So what is our goal? Our goal is to find mu of s. Well, here's mu of s. So if I can figure out these two quantities here, f of s and f of n, then I can solve for mu of s. Let's go to solve. So mu of s is equal to the frictional force, static, over Fn, the normal force. Well, if I know those two things, I'm good. Do I know those two things? Well, let's look at the two force equations. mg sine theta minus f static is equal to 0. So f static is basically mg sine theta. So that's mg sine theta. The normal force, Fn, minus mg cosine theta equals 0. So what's f of n? It's actually mg cosine theta. So if I take a look at this, m's cancel, g's cancel. Let me just go down here a little bit. So I can basically say that mu s is equal to tangent of theta, which, if I take tangent of 47 degrees, I get a value of 1.07, and I'll put 1 in brackets here for unitless. My coefficient of friction is 1.07. So it doesn't matter what the mass is, doesn't matter what g is. If I put this object on the incline, the coefficient of friction I can find out by taking the tangent of the angle. So think about why that's so. Think about why g doesn't matter. If you went to any different planet with a different amount of gravity, as I increase this angle, there's a balance between the frictional force and the weight pulling. So if I go to different planets, a larger gravity, I might have a larger force pulling down this way, but then also this is larger, which increases this force as well. And mass isn't a factor because, as we've seen before, if you drop something just from rest, just straight down, mass has no factor on the pull of gravity there. So again, same methodology for solving a force problem. We draw an FBD, we sum the forces. If we have a friction type problem, we get an extra equation. This can be S for static, or if it's moving, K for kinetic, and then we solve.